Our second example is this one here. It's a little bit more difficult, mostly because one of the brackets looks a bit odd. Okay, instead of writing x minus 2 or something like that, we've got 2 minus x. So it's kind of round the other way. It's not the way that we're used to seeing. But the logic still applies. Okay, to get the sketch of this, I'm still going to get the y-intercept. I still want to find where the x-intercepts are, and I still want to find where the vertex is. And if I can get that information, then I'm set for my sketch. So let's just dive straight in. I want to find what my y-intercept is. So x is equal to 0. So I'm going to substitute into the equation. Y equals minus 3. Whoa. 2 minus x, which is 0. X plus 10, x is 0, plus 10. Working this out, 2 minus 0 is 2, 0 plus 10 is still 10, and I get minus 60. Now, finding x-intercepts. Actually, I should summarize. I'll just summarize that information up the top here. So my y-intercept is minus 60. That's going to be one really important piece of information to graph. I want to find my x-intercepts. My y is going to have to be 0. So I'm going to take the same equation, but I'm going to put 0 in for y. Again, I'm just going to rearrange that and put the unknowns on the left-hand side. If you are okay without doing that, if you're happy to work with them on this right-hand side, that's totally fine. It's just, it seems a bit more natural to use them on the left, but you know, that's just what I'm familiar with. So here we have another situation of the null factor theorem. In order for the result of this multiplication to be 0, one of these three things has to be 0. Either minus 3 is 0, or 2 minus x equals 0, or x plus 10 equals 0. And we're asking these equations, when can these happen? What values could x have to make each possible thing 0? Now, it doesn't matter what x is, negative 3 is never 0, so we can rule that out as an option. Looking at this middle one, this middle 2 minus x equals 0 is only going to be 0. 2 minus x is only going to be 0 if x equals 2. And this expression here can only be 0 if x equals minus 10. So the equation, the quadratic equation, will only have a value of 0. The y value will only be 0 when one of these two conditions happens, when x is minus 10 or when x is 2. So they are going to be my, oh, went too far, 2 x-intercepts. Okay. Final thing we need to work out is the vertex, and as I said before, it's probably the messiest when it comes to this stuff, but it's not too bad. The vertex is always halfway between, oh, I can't use my shorthand well, between the intercepts. And I should say the x-intercepts. The two x-intercepts are 2 and minus 10. So I want to find halfway between 2 and minus 10, so let's average them. So 2 plus minus 10 divided by 2. 2 plus minus 10 is negative 8. And that divided by 2 is negative 4. So that's the x-coordinate of my vertex. Okay, and now I just got to find the y-coordinate. Now it turns out it's not very nice for this one. So to find the y-coordinate, I need to ask the equation, what happens when x is this x value? What happens? Well, y equals negative 3. 2 minus x, x plus 10. Let's put minus 4 in. And 2 minus minus 4 is 2 plus 4, which is 6. Negative 4 plus 10 is also 6. And this is equal to negative 108 if we do negative 3 times 6 times 6. A few ways you can do that. If you've got your calculator, it shouldn't be a problem, but it is negative 108. Okay. So let's have a go at sketching what this thing looks like. I don't have a ruler, so unfortunately I can't do up a really nice set of axes, but hopefully, well actually if you are doing this in a test, you are expected to use a ruler to draw your axes at least, even if for nothing else. So it is a sketch, so it's okay to be a little bit scrappy. I've just done two axes that were both wrong. What I should have done is looked carefully at my values. I need to get a negative 60 on this thing. I also need to get down to negative 108. Okay, so it's kind of heavily negative in the y direction, and it's slightly negative in the x direction. I've got a minus 10 here. Okay, now because the discrepancy between these numbers, my graph is not going to be to scale. My x and my y axes are not going to be in the same ratio, but you know, that's okay, as long as things look okay on each axis. So I'm going to do some of this. Okay. Now I'm just going to mark roughly what 2 and minus 10, so my two intercepts. Yeah, that looks about 5 times further from the axis than this one is, so that looks a plausible 2 and minus 10. I've got to do a vertex halfway between them. I'll just go down as far as my diagram will let me, and I'm going to sketch each side of my parabola. Now if you're not working on a computer, and you can easily flip the page, the trick, if you're sketching these things, it can be beneficial to actually turn your page. I've gone to out of full screen, but that's okay. So this looks about right. There we go. It's a decent sketch. It's a little bit wonky, a bit lopsided, but you know, whatever. So there we are. I've got to mark a couple of other points. My y-intercept I need to mark at minus 60, and I need to mark my vertex at minus 4, minus 108. And that's the sketch of this graph. Before I go, I do want to just make a bit of a comment, because a few people might have noticed that this has a minus 3 out the front. So you might expect this parabola to be going the other way, to be concave down. Now that is a reasonable assumption. Most of the time that's the case. The problem is this isn't in strict intercept form because of this factor. Okay, this factor is a 2 minus x, which actually ends up flipping it back the other way. So if you want to see that a bit more clearly, we can actually just do a bit of algebra with the equation. It was minus 3, 2 minus x, x plus 10. What we can actually do, I'm just going to leave the minus 3 there, I'm going to leave the x plus 10 there, I'm going to play with this odd looking factor here, and I'm actually going to factorise a minus 1 out the front of it. So that would give me minus 2 plus x in here. Now that minus 2 plus x I can swap around the other way, like this, and I can actually bring that minus 1 out the front. Minus 3 times minus 1 would be positive 3. So this is in fact the same equation, but written without those x's round the other way, and it means that now we've got a positive number in front, and so that is why this parabola looks concave up rather than concave down like you might expect.